All right, question 8 is a very interesting question. Okay, so this is the 2019 paper. So it asks you for the largest number which divides this expression as this expression varies for all the primes a and b greater than 5. Okay, does that make sense? And so if you were to do this question, okay, um, you would literally make so much progress by just substituting primes in. That is crazy. Okay, that makes sense because at the moment you substitute a prime in, so if you substitute
7
seven,
and 11.
7 and 11, so obviously you wouldn't substitute 7 and 7 because you actually notice that you'll get actually zero. Okay, so zero is the only number that has infinitely many factors. Okay, but once you got 7 and 11, you get something non-zero, and as soon as it's non-zero, that largest number has to be a factor of that. It's a fixed number now, right? So now you're in the sort of I can guess the rest of I'm just guessing factors of this number now. Okay, so so that's huge, especially if you have time, right? Because that always gives you a chance to get okay. But what people don't realize is if you just kept doing that for different primes, you literally like narrow down the answer so much that like you'll consistently literally get the same number past a certain point, like the same factors which are in common to all those numbers. Okay, so if you literally just kept plugging in primes and wrote the answer that you would guess if you did that, you would solve this question in 2019. Okay, and actually that's how a lot of question eights are solved. Okay, because to actually fully solve it is actually really hard. So and for some reason the questions are always like you can consistently like every year you can always get lucky somehow. Like doing this way has not been punished. Okay. But how do you do the question properly? Okay. So so the question of doing it properly, it's about divisibility. Okay. And divisibility is destroyed by modular arithmetic. Okay. So for example, let me show you something like pretty cool. So consider this expression mod A. Okay. What is this expression mod A? You know what mod A means?
Yeah, I know. Reduced mod
Set A equals 0, remember? Set A equals 0.
a to the 0 to the power of 5 is 0.
Yeah, 0 times anything is 0, right? So that's 0. What's 0 to the power of 5?
0.
0. So then you get what?
Just b to the power of 5.
B to the 5, yeah? And the question is B to the 5 0?
Yeah.
It's not 0, right? Because for B to the 5 to be 0, it means B to the 5 has to be divisible by A, right? But a different prime power can't be divisible by another prime. You know what I'm saying? Like 3 to the power of 6 can't be divisible by 2. Yeah? 3 to the power of 6 is only divisible by 3. Yeah? As a prime. So you already know that this expression is not divisible by A. Okay? And since it's symmetric in A and B, it's actually not divisible by B either. Yeah? But you don't actually even need that because if it's not divisible by A, right? And A varies through all the primes greater than 5, yeah? Can you see that this expression cannot be divisible by any prime greater than 5? Like, cannot consistently be divisible by a prime greater than 5. Does that make sense?
So you could just try every single one now.
So, for example, a prime greater than 5 is 7, right? Okay, well, then you put 7 as A, and then it's not divisible by 7, right?
Yep.
So literally, it's the number. The answer can only be powers of 2 times powers of 3 times powers of 5. Yeah. Okay. So that really limits it. Okay. And what powers of 2? What powers of 3? What powers of 5? Well, if you actually just try primes, it actually really limits that as well. Okay. Okay. Then what do I mean by actually trying primes? Okay. So this is where the quality makes a difference. Like if you literally had to sub it into that expression, you might have a much harder time because it's hard to find fifth powers, right? It takes a while, but it's not impossible, yeah?
Yeah.
And it's also it's a funny thing. It's like it's always like it also depends on how good you are at calculating and stuff, right? And if it's routine, you can do it fast. It might not be the best way, but it's a way, right? Okay. But what else can you do? Okay, so basically one of the key things about sort of maths Olympiad competitions and the existence of number theory, right, is that now your algebra factorizations have a different purpose, right? Your algebra factorizations actually give you integer factorizations. Does that make sense? So now when you factorize algebra expressions, you're doing it by, it's a number theory thing. Okay? So look at this thing. So how do you factorize this expression? Okay. Does anyone? Okay, so maybe instead of
Divided by a plus b.
there's a factor of a plus b. Yes, that's good. Okay. You see any other factors?
A cubed plus b cubed.
A cubed plus b cubed. I don't think that's a factor. Okay, so one thing. Okay, let me tell you one thing that gives away a factor. So you remember when I said when we sub in a equals b, you get 0, right? So notice what else is equal to 0 when you have a equals b. Is this thing also equals 0? Yeah. So actually, when a equals b gives you 0, shows you a minus b is a factor of the expression. That makes sense? So there's a lot of hints to tell you what the factors are, even if you can't find them. Okay. Okay, but if you actually wanted to factorize it, there's a kind of a just like a nice little way. So if you have a to the 5 minus, that's a to the 4 times b, right? Plus b to the 5 minus b to the 4 times a, right? Yeah. And so you can see there's a common factor of a to the 4 here, yeah? And that's a minus b, yeah? And this is b to the 4 outside of b minus a, yeah? And see, a minus b is just the same as b minus a, but negative.
Yeah.
So then you actually get a common factor of a minus b, and now it's a to the 4 minus b to the 4, yeah?
Yeah.
Okay. Now a to the 4 minus b to the 4 is actually a difference of 2 squares, right? You get a squared minus b squared. So don't just wait for me to tell you. If you see it, you just point it out, yeah? A squared plus b squared, yeah? And then what's next?
And then you could use the difference of 2 squares again.
Yeah, so a squared minus b squared is the difference of 2 squares, right? So a squared minus b squared is a minus b times a plus b. Okay, so this is a minus b times a plus b. So in the end, you get 2 a minus b's, yeah? Which is a minus b squared, 1 a plus b, and then an a squared plus b squared, right?
Yeah.
Okay. So with that factorization, it's actually much easier to sub in values, okay? Because in the end, you only actually care about the factorized number. You don't actually care about the absolute number, right? Because you only want to know what factors divide. So for example, if I were to sub in a number now, okay, so a prime is 7, another prime is 11, right? Can you see I could quickly get, this is 4, the difference is 4, right? 4 squared, the sum is 18, yeah? And 49, so 7 squared plus 11 squared, so it's 49 plus 121 is 170. Is it 170?
Yeah, it is.
170, okay. So in terms of prime factors, right, I got what, like 17, yeah? Shh. So 17, 2, and 5, yeah? And here I got 2 and 9, yeah? Right?
3.
Yeah, sure.
You mean 3?
Yeah, so the power of 3, yeah, 3 squared, yeah.
Yeah.
Okay. But what that means is it automatically means that obviously I don't care about 17, right? But it automatically means there's no 25s, yeah? In the actual answer. It's either 5 or there's no 5, yeah? Okay. And it means it's either 3 or 9 or there's no 3, yeah? And it also means that there's like what, like there's at most like 6 or 7 2s, yeah? That makes sense? Okay. Okay. So I'm not going to give you the exact solution from here on in, because I don't think it'll necessarily help you, but I want to give you an idea. And so basically, if you just sub in more primes, right, you get a pretty good idea. It's either going to have 5 in it or it's not. It's going to either have 3 in it or it's not. And it's going to either have 2 to the 5 in it or it's not. Okay? And how do you tell? How do you tell if it has a 5 or a 3 in it? Okay? So this is my exercise to you. Or maybe I'll show you how to do it with 3, but you have to do it yourself with 5. Okay? So you consider it mod 3. Okay? Because you want to know if it's divisible by 3 or not. Okay? Consider it mod 3. Yeah? The only numbers mod 3, okay, are 0, 1, and 2. Okay? Alright? But we're not allowed to have 0 for A and B because A and B are primes greater than 5. They're not divisible by 3, right?
Yeah.
So literally there's only 2 things that could be, right? And you just need to try all the possibilities. So if they were both 1 or they were both 2, then the difference would be a multiple of 3, right? If one of them was 1 and the other one was 2, the sum would be a multiple of 3, right? Yeah? So no matter what, it's going to be divisible by 3. Does that make sense? So you can prove that it's divisible by 3 like that. Okay? So I want you to think about how that would work for 5 at home. Okay? And maybe I'll send you another video for the 5 one. But for the 2 one, I'm tempted to spoil it. So can you maybe come up with an argument why it might be divisible by 16, if not 32? Okay. So because A and B are both odd, right? Yeah. That means anytime you do like A plus B, that's going to be even. A minus B is even, right? Odd plus odd is even. Odd minus odd is even. And you basically have 4 factors here where they're all even. So that means there has to be 4 2's at least, right? Okay, why is there 5 2's instead of 4? Okay, it's because you have something like this, okay? So there's a common fact that says if A minus B only has 1 2, then A plus B has 2 2's at least. Okay? So basically if one of them is not divisible by 4, the other one is. Okay? And that fact can be proved so many ways, but one way is modular arithmetic. Okay? For example, how could A plus B not be divisible by 4? Yeah? Basically, and A and B are odd, right? So A and B each are either 0 or 2 mod 0. They're either 1 or 3 mod 4, right? 1 or minus 1. So they can't be 1 and minus 1, otherwise it'll be divisible by 4, right? So it has to be 1 and 3. Sorry, it has to be 1 and 1, right? Or minus 1 and minus 1. But if they're the same, then this is going to be 0, right? So no matter what, one of them is going to be divisible by 4 and the other one isn't. Okay? And that's where you get your extra 2 from. Okay, so that was pretty difficult, but this is one of the harder questions. Okay? And we're kind of in speedrun territory as the class is running out of time here. So, do you have any questions about that?
I think you might need to send the recording.
Yeah.
Oh yeah, I definitely. I'll send you the playlist. I'll do one better. I'll send you the whole playlist. Okay.
So